Here we have two identical triangles. They're duplicates of each other. We could also say they are congruent with each other because they are identical in size and identical in angles. But what happens if you rotate or reflect one of the triangles? Does that change the congruency of these triangles? Well, let's go and find out. What I'll do is I'm going to rotate triangle DEF. So I'll use one of my tools here, rotation. And let's go ahead and rotate this. Now, as you can see, if you can keep track of either one of the angles or two of them, nothing changes. The side lengths don't change and the interior angles do not change. And so if you rotate a triangle, it does not change any of its dimensions. Therefore, rotating a triangle does not change its congruency with another triangle. So this makes no difference. The same is true for reflecting. So if we go ahead and reflect, let's put this back to 0. All right, so if we can go ahead and reflect this now, reflect. I'm going to try and reflect this horizontally. Let's make that a little bit higher up. Maybe that's fine like that. All right, if we go ahead and flip this or reflect it, now we've reflected. If we just go ahead and move or translate this back up to the top here, as you can see now, this triangle DEF is kind of like a mirror image. We can make it look more of a mirror image by rotating it now. So we reflected it, but if we can now rotate it, I guess if we go to 180 and then we move it, you can see that they're essentially mirror images of each other now. So all I've done is I've reflected and now just rotated around. So now they look like mirror images. But we do know they came from the same triangle. One was just a duplicate. So as you can see, the same dimensions are still true, and we still have the same side length. So therefore, rotating and reflecting a triangle does not change its congruency with another. It just gets a bit confusing when you want to try and determine its congruency if you haven't actually originally rotated or reflected it yourself. So if you're given the problem that you can see on the screen right now, well, how do you determine if they are congruent? Because it's hard sometimes to see if they've been reflected or not. Well, if you look here, I'll go ahead and use my pencil. If you circle on your first triangle ABC the side length, you can see that the side length is, surrounded or in between the two angles that are both identical with each other. So as you can see, the side length is in the middle and the angles are on either side. So therefore, they're in the same position on each triangle, and they must be congruent. Let's go ahead and take a look at another example. I'll just switch apps here. Let's go back to